interested in building one, or maybe if you're actively building one, improving it. All right, cool. Well, goes without saying that the world of software development is changing and changing rapidly. I, for one, have spent my whole career, 10 plus years, on the product side, and I'm normally the girl that's nagging the developer, like, can you fix this, can you fix this, can you fix this, can you fix this? And for the first time ever in my whole career, I'm now in a position where I can fix it, right? I don't have to go chase a developer, I don't have to fight for priority at the top of an infinite running backlog. I can just go in there and fix it, right? And not only can I fix it, I can build it. You're in a position now where the boundaries of entering, what it means to be a software engineer and what it means to build software are rapidly changing, right? We've seen advancements in the last, not even 6 months, but call it 90 days, right? That have 180'd what is the traditional software development lifecycle. Even the traditional roles that someone has played, right? From a product manager to a designer to an engineer, and all the nuances in between. The lines are blurring, and they're blurring rapidly, right? Today, one person can do the whole software development lifecycle, with a few prompts. And that's really cool to witness. So today we're really excited to kind of spotlight some incredible companies that are building throughout the software development lifecycle and talk a little bit about how they are kind of, building for the future of the world and the future of the developer experience. So with that said, we'd love to first introduce you to some of our speakers. I'll have Daniel from Deskree with the other mic go around and let the speakers do a quick little introduction. And then followed by those introductions, we'll do a quick lightning round of kind of like product talks, where each company will present, some sort of tooling solution within the space. We'll open the floor up to questions from the audience. So if you have any questions, you will have an opportunity to ask, and we'll continue from there. So with that being said, Daniel, our first speaker.
Hi, my name is not Daniel, I'm his brother. My name is Dimitri, I'm the founder of Deskree, and we are a knowledge intelligence layer for enterprise software systems. I'll pass on next.
Hi, my name is Sarah, and I'm from PostHog. I am a context engineer, and I work on our AI onboarding wizard.
Hey, I'm Christian. I'm founder of this company called Charm that builds command line tooling, infrastructure, and AI agents for the command line.
I'm not taking a picture of your screen. I'm just doing that. Oh.
Hi, Sean Carolyn, recovering sysadmin, current sales engineer at Grafana.
Hi, my name is Nori Tatsumi. I work for the engineering team of Arthur, a AI performance and governance company.
Awesome. Well, those are the intros, so that's who you'll be hearing from throughout the talks this evening, and we will go ahead and kick it off with our first talk with Deskree. You're allowed to clap, it's allowed.
Okay, hi everyone. While I'm setting this up, I think it's gonna go wrong the first two tries, so bear with me. Okay, so as I said, okay. Oh, nice, perfect. You guys see this? So, hi everyone, do you hear me well?
Yes.
Beautiful, nice. Okay, once again, my name is Dimitri. I'm the founder of a company called Deskree. So today, what I'm gonna be talking about is just want to share with you some of the interesting things we've seen in the last year, especially since we done the first Future of Developer Experience. Actually, the first one was here in New York last year in June, so almost a year. And a lot of things changed since that time, and there's a lot of things that we've observed in the industry. So I'd love to show you like one of the stories that we've seen, how we solved this, and kind of some of the outcomes we've seen along the way. So last year we spoke with quite well over 100 of Fortune 500 companies, and what we realized is there was one interesting outcome that we see come up in a lot of different conversations. And that outcome was there was a lot of companies that were saying like, hey, like we are not able to use AI to its full capabilities because we cannot see that AI is able to reason accurately in large production enterprise systems. They're like, oh, this is interesting because you're in an early stage startup where you can vibe code the entire thing over the weekend, but yet somehow this becomes a bottleneck in a larger software. So we started diving deeper and realizing, okay, why this is happening. So one thing that became apparent pretty quick is if you look at larger software ecosystem, we as an engineer, we don't use just the code base. We rely on a lot of different data points to make a weighted decision to produce a certain outcome. And one thing we've seen a lot when it comes to one engineer doing a job is, okay, I'm gonna take this code base and I'm gonna vibe code the hell out of it to see what's happening and in a full control over the entire process. However, it's basically, if you think about this in terms of the context, it's like trying to understand how the entire picture is gonna look like just by looking at one piece of a puzzle, right? So one thing we realized is that, okay, for AI to be able to create accurate piece of code, okay, it just needs more than a code base to understand what's happening on the infrastructure layer, how that piece of code is gonna represent the service, how that service is gonna talk to others, and so on and so forth. So all this comes down to, okay, now what it means is that your AI needs to have more context. So, and in a larger company, that usually means doing things that engineers don't like doing the most, which is talking to other people and trying to figure out, okay, how can I get this piece of information out of this team? I need to go through 3 or 4 meetings, trying to piece it all together. Because in larger environments, that knowledge is scattered across teams, individuals, tools, and so on and so forth. And then ultimately, once you gather all this knowledge together, the next challenge is, okay, I have this knowledge all in one place, so what do I do with this? Because there's certain limitations. Like one is, okay, there is a context window limitation. When you work with an AI tool, you cannot just dump all the data in and expect to have a good answer. There is that limitation. Now, when the other way to solve this is a multi-agent setup. However, the challenge there is a degree of hallucination with every single request you do in the multi-agent setup, so you're basically stacking them up on top of each other. So, and in larger and more complicated problems, that accuracy is it's pretty steep price to pay. So, and based on this, what we've seen is companies saying, okay, like we cannot trust output of AI tools when it comes to high priority tasks or things like that, and that, it's gonna create different bottlenecks for us in the sense that we can write a piece of software fast, but our QA is going to be stuck trying to review all of that, and so on and so forth. So what we did is we had to figure out how we can solve this to all the people we talked to. So we came up with a way that consists of 2 important components. So ultimately, the goal of the tool that we built at that time was, okay, how to reason across the entire software development lifecycle within the company. So the solution to us came in 2 important steps. So one is, we said, okay, what if there was a unified knowledge layer that would basically be able to gather information from different corners of your ecosystem? And we sliced that into 5 different layers. The code base, service-to-service communication, infrastructure, monitoring observability, and ops. And the goal there was, okay, instead of just pulling all the data into one place, can we find how the relationship between all those components work? How a piece of code represents a service, how that service communicates with others, how it's being deployed, what kind of infrastructure product it uses, who are the people behind that service, and so on and so forth. One thing we realized, for this to be accurate, it has to be predominantly deterministic process rather than LLM driven to make sure that in large system is not going to cost tens of thousands of analysis and tokens, but on the other side, the result can be meaning that if we run this analysis 10, 20, 100 times, we'll still see the same result. Now, and the second part of this was, okay, once we have the knowledge mapping, how can we persist this data and what kind of data we should persist and what kind of data we shouldn't. So all this resulted in us building essentially a knowledge layer that allows you to pull this data from different places, map it out, persist parts of it, but then for this to be, you have to be able to interact with this. So the second component of our system became, we call it a reasoning layer, and there's 3 important parts about this, right? So there's 3 layers of interaction with this. One is deep research, which is mostly used by engineering managers, who want to run complex planning, analysis, migration planning, modernization planning, you name it. But when their deep research can be run against that knowledge graph data. The second thing, the way it exists, is a layer between you and your favorite AI tools, like Cursor, Cloud Code, and others, where we use this knowledge to basically power up your tools and give them the necessary knowledge that they need. So for example, let's say you're working on a piece of API, you're changing this with Cursor, and we can be the tool that will tell you like, hey, do you realize that if you make this change now, there's a service out there that uses this API endpoint. And if you change the data structure, that service might go down, so be careful, right? So it's things like impact radius and so on. And the third thing was, okay, so there is a lot of different agents or other like CI/CD tools and other processes that companies already built where this data and knowledge might be useful. So what we did is we created API and CI to be able to tap into this data in a flexible to fill your needs. So this is a little bit of a journey of the problem we found, the solution we created. And one thing is also apparent is, okay, the environment where developers operate literally changes on a daily basis. I remember like 1 year ago when we talked here in Europe, we said, okay, MCP is coming out. Like at that time it was already 6 months old, but it's gonna be like a new standard, everybody's gonna be using this. One thing we realized, and this is like 3 outcomes that I wanna share with you, like learnings from that process. One thing was that, yeah, MCP is great, a lot of companies are adopting this, but as of recently, a lot of you guys know that CLI is becoming a new trend in terms of like companies seeing the result that CLI can be more accurate or faster or using less context. We've actually seen quite the same results. So we initialized the MCP tooling, but we've comparing this with our CLI performance, and we see double-digit improvements in our evals. Because, not only because it uses less context, but because it's a lot faster, and there's a lot of other reasons for that as well. The second thing is when it comes to collecting knowledge, one thing that is extremely important is how fresh that knowledge is.